Now, when you say specification, you talked about that specification. It sounds pretty straightforward. Could be a document that someone feels looks the same like a standard product, so what's the big deal? But what is actually involved in generating or creating the specification?
A lot of work is the first answer, I would say. It is not just a piece of paper. It's not just somebody making some notes and putting them out there, and then once customer signs it, then the paperwork starts. Actually, because the CAS, the product specification, is also a letter of warranty. This is something that we are held responsible for. Customer will hold us responsible for this, for meeting all the specifications within this document. Therefore, it's really, really important that we go through every step, every little detail to make sure that we don't promise anything that we cannot meet when it comes to the end, when the product has been developed and produced. Another thing is verifying all the, for example, the mechanical tolerances. We need to have a review there, make sure that the bezel or the display or the backlight, that they fit together, the parts, that the mechanics that we have designed fits together and will not create any conflicts over the entire span of temperature variation, for example, or whatever it is. So there's a lot of technical evaluations behind the product specification.
Based on my experience, I can tell our viewers that it basically contains all the things you need to know about the cosmetics, like scratches, defective pixels, power consumption, what is to be expected with such a product. As you described, naturally, a lot of work goes into this.
Absolutely.
And so the PCB design and the circuit design, that's also part of EDT's workflow, right? Your expertise.
Yes. We cover all the aspects of the entire product. So that also includes designing the FPCs and the PCBs.
And I noticed that with the rise of CE certification, ESD, EMI test results have become really important, and that's also taken up a lot of work to have an EMI and ESD compliant design. Now, after the customer has approved the specification, what's the next step?
There's a lot of internal documents that needs to be prepared, and before we can actually order the material itself, that is a big part of the process that starts afterwards. Then we also need maybe some assembly jigs, some test jigs, and then obviously we need a few weeks time to do the necessary bondings and assembling the module before we can deliver out the first samples.
What does it take for a company with more than 1,200 employees, obviously hundreds of them working in production, to achieve consistent quality over years to come in production?
First of all, a very good system needs to be there. We need to have a lot of documentation. That is descriptions of each step of the production, assembly processes, bonding processes, and bonding includes also chip on glass bonding, FPC bonding. It includes optical bonding, glue bonding. And then, of course, the operators need training, and the experience of doing these processes is of course very, very important when it comes to providing a good quality over a very, very long time of period. But without this constant control of processes and checking checkpoints, without that, it would be quite impossible to provide a consistent quality. But we have that in place, yeah.
there's also part of traceability, which is another important
Absolutely.
subject. Now let's briefly talk about incoming quality checks. This is something that is done, I guess, on several components.
Almost on every component, we have to do the incoming inspection. And you can imagine that's quite a lot of work, especially when you do more than 500 different modules every year. And when we take in new suppliers, they will be audited to match the quality measures and standards and the expectations that we have.
And what steps are involved during production to ensure consistent quality? It's not just the incoming inspection, but you mentioned earlier checkpoints.